originally looking to be there in person, but some family stuff came up and I wasn't able to, but still happy to give the talk online. So, so what are we going to talk about today? We're going to talk about agentic access, and we're going to talk about how OAuth can get you in, but Zero Trust keeps you safe. I don't always put a slide up like this, but since I'm not in person, I'll just give a brief overview of who I am. My name is Nick Taylor. I'm from Montreal, Quebec, Canada, so on the East Coast in Canada. And I'm currently a developer advocate at a company called Pomerium. We'll get into what that is, because I'll be talking about what's called an identity-aware proxy, which is the core product of Pomerium. This isn't a sales call though. We're an open core, always self-hosted, so lots of deep roots in open source. And these are places you can find me online, and also I'm not a big fan of spiders. So we're gonna cover a few things here. Basically, we're going to go over what is MCP, so the Model Context Protocol. This might be something you're aware of, or maybe it's something you're new to, but this is something that is fairly new. It's like a year, well, I say fairly new. It was literally a year old, the protocol, on the 25th of November this year. We'll get into that. We're going to talk about what Zero Trust security is. And we'll go over a few more things here, some best practices, why Zero Trust for MCP, and we're going to talk a bit about VPNs and traditional perimeter-based security, and how OAuth is a big win in MCP, but I think we can do a bit better potentially. Whoops. Okay. So the Model Context Protocol is something that defines a standardized interface for tools that LLM agents can call to perform actions or retrieve context. So this is something new that came out of Anthropic a year ago. And there's, if you use editor like Visual Studio Code or Cursor or Windsurf or whatever you're using, you might be familiar with MCPs that run locally, the standard IO ones, but there's also remote ones as well. So we're going to focus more on the remote ones today, because we're securing those, because local ones you're just running locally. And with MCP, there's clients and there's servers. So there's the servers, like I just mentioned. The clients are something as far as I know, right now, it's VS Code is a fully compliant MCP client. So that means it can register MCPs and use them. Claude as well provides this. Goose, which is an open source MCP client, as well as I guess all-around tool for all things agentic. That's open source from the people over at Block. ChatGPT released a dev mode about maybe a month ago, and they also allow you to use the Model Context Protocol as well. And yeah, the other thing to mention is we won't get into it really, but an MCP server can also be an MCP client if it needed to call other MCP servers. And we'll have a demo a little bit later here, but here's a screenshot in Claude online. And you can see here I'm making a tool call. This is a MCP server that I built for anybody. You may or may not be familiar with it, but there's a blogging platform for programmers called dev.to. I used to work there and love working there, but since moved on. But they have an API, so I exposed that API as a set of tools that I could use in a MCP server, and I can ask stuff. So here, for example, I'm asking, can you get the latest articles from me, my username being Nikki T Online, and we can see. Oh, sorry, that was actually in Goose. Over here is in Claude. And and this is just to show that because it's a standard protocol now, you can use it in different clients as long as they're MCP spec compliant. And here it is in ChatGPT. So just different views to show you that it's universal. And people always say that MCP is the USB-C of like connecting things for agentic, because like you don't have to cobble things together now. Like you can just use all these remote MCP servers. It's a good analogy, but I'm also a little nervous because I feel like there's probably going to be another type of port in the future. So, that will have another dongle. So I don't know how long that analogy will work. But anyways, I digress. Okay, so we're going to talk a bit about what zero trust security is here. So um, I'm not sure if anybody here is familiar with zero trust security. I'm not in the crowd, obviously, we're online. If you have any comments, feel free to drop them. But we're going to just kind of go over what zero trust security is. So zero trust security is, and we'll do just a short history lesson as well. So this came out of Google. I think it was like the early 2010s, or it might have been 2009. Google had this massive data breach. Somebody got onto the VPN and they wreaked havoc at Google, or at least parts of Google. And they're like, okay, we have to rethink things here. So basically, they came up with something called zero trust security. And I can just come over here for a second. And so if we look at Beyond Corp, Wikipedia. So if you want to read up papers, and this is where they get into like all the things they did. But one of the main things, if we come over here, is there's no implicit trust ever, not even inside your network. So if you think of traditional systems like VPN, this was perimeter-based security. And, the initial, I guess, thesis with perimeter-based security was people would log in at the start of their workday or whatever they're connecting to, and it was assumed that if you were able to log in, you were a trusted user. And that might have been okay a while ago, but nowadays, um, really, there's state actors, there's people trying to do bad things on your network. You just have to assume that. And so what Google did was, yeah, they came up with zero trust here, and it's the no implicit trust ever. There's this strong identity verification at every step. And, you want to always stay with the least privilege principle. So you want to give only the access that's needed, nothing more. And there's also this continuous authentication and authorization of each request. Excuse me. And this notion of context-aware enforcement. So it's not just like, is Nick logged in? It's like, is Nick logged in? Is he part of a certain group? Those are standard things that you're probably familiar with from just regular role-based access. But this will also include like device identity. Like, is this a work laptop? Is this a work-approved device? What time of day is it? Where is the location? And yeah, every request is validated, unlike traditional perimeter-based security where you just get on the VPN and then at that point, it's assumed you're trusted. So if we put all those things together that I was talking about, it creates something called an identity-aware proxy, and it's one of the core building blocks of zero trust. It enforces that authentication and that context-aware policy before any access is granted every time. So like literally, if we think about like a web application, because this can be used elsewhere too, but imagine you go to this secure site, you're going to log in, and it'll check that, through the context-aware policies, are you allowed to do this thing? And if you are, you're granted access to whatever the internal resource is. And this happens literally every time. And we'll talk about that here. So this is the identity-aware proxy, where you see like the policy engine and the proxy, and there's this identity-aware provider. Those three things together make what's called the identity-aware proxy. So the internet over here up top on the left, that's where the user is. That could be, me at home. If I was working in a physical office, I could be at an airport. It doesn't really matter, like where you are now in terms of like accessing these things doesn't matter. So like, unlike with a VPN, you would have to, you'd either be at your office, like when I used to work at Autodesk, I would be in the physical office, so I'd already be on the network, so I wouldn't need the VPN. Or if I was from home, I would have to connect using the VPN. With this, there's no additional software. You're just going through the AnyWare proxy. So basically what happens here is with an AnyWare proxy, you always have like a publicly accessible URL. So let's imagine, I don't know, secret.bsideswarsaw.com. And that URL is going to go to some super secret internal resource that, only people, at BSides Warsaw can access. So me as the user, I'm going to say I'd like to go to or secret.bsideswarsaw.com. It's going to come into the AnyWare proxy. The first thing it's going to check is, okay, is this person authenticated? Okay, no, they aren't. So let's go ahead to the identity provider that they've decided to use. So, for example, like Google, Okta, GitHub, whatever it is, Keycloak, Keycloak's a good open source one too. And you're going to be authenticated. Now, assuming you log in, and it's valid, it's going to return some claims in the JWT that comes from the IDP, the identity provider. And then the AnyWare proxy is going to go, okay, Nick is logged in. He's trying to access secret.bsideswarsaw.com. Let's check the policy engine, because the policy engine will have policies about that particular route, which is the secret.bsideswarsaw.com. And it's going to go, okay, Nick has an email address that, the domain is bsideswarsaw.com. So that checks out. That's the policy to access this resource. And it goes, okay, so Nick's logged in, the policy check is passed, and only at that point do you go through the reverse proxy to the actual resource. And that's the flow. And this happens literally on every request. And, this is something, the AnyWare proxy is, you install it at your network edge. So wherever you're hosting your internal applications, AWS, Google Cloud, or, people are multi-cloud too. And so you have that at your network edge. So there is technically some latency, but it's honestly negligible. And that's why you're able to like just constantly verify all the time. And these policies in the policy engine, they're dynamic. I gave the simple example of just a email, like I mentioned before. What's the security posture of the device that Nick is on? What time of day it is it, like maybe I can only access this resource from Monday to Friday during regular working hours, not on the weekend. And, these policies can be even more complex, a combination of all these things. And that's essentially what the AnyWare proxy does. And, we've been used to traditional systems that assume you have like a login portal, like a literal login form. And, but now with LLM agents, internal automations and developer toolings, that's no longer the case. You're acting on behalf of a user in a lot of scenarios. And so there's different risks, and we need a standard way to expose those securely. So let's get back to MCPs, because we are talking about securing them. So this is straight from the MCP security best practices. I'm just going to name a few things here, but feel free to check out the link here or in the resources. I'll have a QR code that you can snap after if you want to just check out the slides with all those resources too. But some of the things are: place MCP servers behind a proxy. You want to enforce authentication. You want to validate the token audience and scopes, and you want to prevent token pass-through, and you want to preserve user consent, and you want to audit all access. And even though it doesn't really say this in the MCP security best practices, this is kind of screaming zero trust security. So, an AnyWare proxy would fit really well with this. Yeah, okay, so that's what I just said there. I'll just take a sip of coffee. It's a little early for me. Okay, so let's talk about VPNs or perimeter-based security now, just briefly. So, like I mentioned before, traditional perimeter-based security, the way it works, and yes, there's more modern solutions, but typically you log in once during the day. Yes, there might be multi-factor authentication and stuff, but once you're on, you're just considered trusted, or like there's no longer a check. And if we're talking about securing MCP servers, if you're looking to secure an MCP server that's internal, but you want to, for example, use it in Claude Code or Claude or like Visual Studio Code or um, uh, even ChatGPT, you need to have a publicly accessible URL to be able to use those MCPs. Now, it's it's one thing if you just aren't using cloud or frontier-based models, this might not be an issue. But if you are looking to share it on one of those cloud-based or frontier models, you have to expose a publicly accessible URL. So a VPN is not going to work with that scenario. So if you're looking to secure your MCP servers and you're thinking, oh, well, we've got a VPN, so that's a secure way to people access certain things. It's not going to work in this scenario. So let's talk a bit briefly about OAuth and MCPs. I'm not going to go deep into OAuth for a couple of reasons. I'm not an expert, but also, as I mentioned, I've given this talk a few times now. As I mentioned, on the 25th, it was the birthday of the MCP protocol, still fairly new. OAuth only got introduced in May of this year. I was at the MCP Dev Summit in San Francisco, and they had just started talking about this. It got into the spec, and then people started implementing it. And obviously, it's good to have a login flow, because before they were just kind of bare, or you would like add an API token to a header and stuff, which might work if it's just literally you, but like it wasn't really great. So adding OAuth to the spec was a welcome addition. And what this does is you end up getting scopes with the OAuth, so the static scopes to allow you to do certain things, and that's great. But OAuth alone just answers, what can you do? Can I, if in the context of GitHub, do I have the repo scope so I can do stuff with repositories? But it doesn't say like, should you be doing this right now? So this is where the zero trust security comes into play. And so, yes, you can have that repo scope, and this is something you can't change. Like when you deploy this, let's just use the example of GitHub. You assign certain static OAuth scopes, and once those are deployed for that, that's what it is. So when I log in, I'm going to get the repo scope, for example, if you're familiar with GitHub, which I'm assuming most of you are. And so, yeah, so OAuth alone can't enforce like device trust or session-based policies. Like I mentioned, VPNs won't work in this scenario for at least cloud-based stuff, like Claude or ChatGPT. And also in the case of agentic, like for MCPs, we want to that per request policy to check on accessing sensitive systems. So this is where the dynamic based context aware policies come into play from zero trust. And the other thing too is, like we mentioned in the identity aware proxy diagram, you're never actually accessing the actual resource until you're deemed logged in and the policies pass. And then only at that point do you actually access that internal resource, in this case, the MCP. And the other thing I wanted to mention just briefly about zero trust is, with the VPN or perimeter-based security, when you're when you're logged in with perimeter-based security, you have access to the entire network. It doesn't mean like I can log into everything because I might not have access to log in to those things, but I have access to potentially hack to get on there. I like everything's just available on the network, and there's more modern solutions with VPNs now. So like there could be network segmentation, but even with that network segmentation, you still have access to everything on that particular chunk of the network. And with zero trust security, with the identity aware proxy specifically, you're trying to access a specific resource and you only have a path to that internal resource. There's no, there's no east-west traffic once you're in the internal network. It's literally, think of it as like a highway from, just a highway that just goes one lane, no exits. It's straight to that thing. And in the context of identity proxy, that's called micro segmentation, because you literally only get access to the what you need. So that ties into the principle of least privilege too. Okay, so yeah, so identity is just one input if we're talking about MCPs, but zero trust evaluates, who, what, where, when, and why. You get that context. Like I said, it's, I'm going to try and drill this home, but like device posture, session, location, the behavior maybe. And so the policies, these fine-grained access policies, we'll check before every request. And aside from that, didn't touch on it yet, but because you're going through the identity aware proxy, you get observability out of the box because everything's going through this identity aware proxy. You can get your OTel traces and just put that into whatever you use. So that's nice too. And these are, in general, security and observability are important for sure. But in the age of agentic, it's at top of mind for like everybody. So you get those two things out of identity aware proxy, which is nice. Okay, so I'm just gonna talk about like MCPs in the context of Pomerium. Everything I'm showing here is open source, so you can check the repo. I have a link to it. So with the OAuth being added to the MCP spec, this is great, but I don't know if anybody in the crowd at BSides Warsaw in person or watching the live stream, but like, I don't think anybody wakes up in the morning and says, I'm really excited to implement OAuth into my application. So with Pomerium's open source offering, we handle this for you. So the identity aware proxy acts as the OAuth flow, basically, in an MCP server, remote MCP server. And the other thing that's nice is you might have OAuth for your MCP server, but your MCP server might also have a need to access some kind of upstream service like Google. So for example, like if I had, or GitHub. So like we were talking about GitHub before with the repo scope, maybe I have like a GitHub MCP server where I need to access GitHub as well. So I have to go through that whole OAuth flow as well. And then the nice thing is with the open source offering here is even that upstream OAuth flow is handled through Pomerium's identity aware proxy. And the other thing is, so like when you're using an MCP client, so like say VS Code or Claude, you're gonna say like, I'd like to add this particular MCP server. It's going to put you through this whole OAuth flow. And if you do need to use an upstream service like GitHub, it's going to return that token from GitHub to the MCP client. And in the case with the identity aware proxy here, what happens is you still register the MCP server, but what happens is if you do have an upstream service, that token that gets returned there, that stays within the identity aware proxy. It's essentially an AI gateway, even though this is for more than just all things AI. And so that's a nice security feature. So basically, the MCP client just gets this short-lived Primarium jot. And so like even in the case of where somehow it did get stolen, that jot, it's short-lived, so the blast radius is pretty low, versus like the MCP client without like the identifier proxy here would have like the keys to the kingdom for you, whether that's like your GitHub OAuth token, etc. And it's not to say that these MCP clients are going to do nefarious things, but you never know. And the other thing is, just like I've been saying over and over, you can apply these fine-grained policies, but you can also do this not only on, like can Nick access this MCP server or somebody else based on certain policies. You can even laser focus the tools that you have access to in an MCP server. And this is like very important because we're talking about the GitHub MCP, and the GitHub MCP, it will give this static OAuth scope repo. Repo gives you access to do whatever you want to with repositories. They have a bunch of tools, and, and so you can use those tools on any repositories that you have access to. And maybe you don't want some of those tools to be available in an agentic context, or maybe certain people, like imagine, I don't know, you say create a repository, and for whatever reason, the LLM misinterprets it, and all of a sudden you get to tell your coworkers, oh, I accidentally created 700 repos in our org, my bad. So I'll just show here briefly, just doing a time check. We got about 10 minutes. So here you can see the auditing in place here. I've restricted a tool call for, this is like an example I use a lot, where somebody's trying to cook the books. So they're trying to update sales numbers. But right here, you can see that it audited it real time, and then thanks to the identifier proxy, and you can see what it was trying to do, and it tells you why it was denied and stuff. And this is briefly what I was talking about before. So we have routes, and let me go ahead here. Yeah, okay. I'll come to this in the actual user interface to show that better. But essentially, in identifier proxy, you have routes. Routes are considered applications. So you can see here, this is my from route, and then assuming the policies pass, I actually get access to the internal resource. So like, for example, here, localhost 3020. And if I do want to have an upstream service that I want to have access to with OAuth, like I was mentioning before, you don't need to implement these things. You do still have to create the OAuth app, but all you need to do is provide like the client ID secret, the scopes, and the necessary endpoints. Yeah, so basically, there's also the MCP client. You can also build an MCP client with the and secure it with the identiware proxy, and that whole like login flow will be handled because we know who you are and stuff, and we can pass the bearer token. That's short-lived. And again, like I was saying, there's no upstream tokens exposed to the clients when you're using the identiware proxy to secure these MCP servers. So basically, clients don't manage auth; they just pass a secure scope token. Okay, so let's go to demo, and I'm just going to do a quick time check. Yeah, so we got about 8 minutes. So this is perfect. So let's come over here and okay. So this is open source as well. This is a chat client I built this summer for, originally it was to be a short demo for the AI World Fair in San Francisco. We actually use this internally now, so it's not a product we offer, but it's an open source project. This was a way for me to showcase how we were securing MCP servers. Open source, like I said, in the Primarium org, if you want to check that out. So, this is just, think of it like a regular chat app. And, MCPs, all they do is they add additional context when you're asking something, but they can also perform actions. So I'm going to go ahead and connect the GitHub MCP here. Now, this is also open source. GitHub has a hosted GitHub MCP server. From what I could tell, that is not open source, but they have a standard IO MCP server. So this is one that you could use locally. I forked it and I converted it to an HTTP streamable MCP server so that I could secure it with for demos and stuff. But it's open source, so check that out too. So I'm gonna go ahead here and let's see here. It might be able to tell me like what. I think it should be able to tell me what GitHub tools there are. Now, okay, yeah, so there's a lot of tools. Okay, yeah, so it's just telling me what it can do. So we have this repo scope. So if we come back here really quickly, so here's my route. So this is my from route. This is the publicly accessible URL, and this is where it's going to in my Kubernetes cluster. And if we look at the other settings, like I was talking about, and I'm just showing this in the UI just because it's easier, but like in the open source, it's just in YAML. But essentially, you just have to have your client, and then you set your scopes here. So, and that's essentially it. So you can see here, I have the repo scope. So let's come back here. And so let's just do a new chat, and I could say, and I have this zoomed in, so it's usually not this scrunched together, but it's just more so people can see it better on the live story called BSides Warsaw 2025. Create a PR to update the README with Nick gave a talk and merge the pull request. So I'm just going to go ahead and copy this. So we're going to go ahead and like this is live demoing, so this is not a recording. So hopefully my Kubernetes cluster is still alive. It's for me. So what's going to happen here now is we're going to see it's calling the MCP server for GitHub. It's going to create a repository. It's getting the file content. It's trying to create a branch. It's creating a pull request, and then it's going to go ahead and merge that. And everything was successful. So let me just go ahead here and open this to show you this is not smoke and mirrors. You can see here, this is literally live, just created a second ago. You can see it merged it. And if we look at pull requests, there was one. So you can see here the GitHub MCP server went ahead and did this. And it's merged now. Okay, perfect. So let's come back here now. And we'll do a new chat. And I'll just say part 2. So there's a policy here that I created called no merge pull request. So basically, again, this you can do this in YAML too. I'm just doing this for just it's quicker to show it here. But in the open source version, it's in YAML. But I'm saying this MCP tool, if it's merge underscore pull underscore request, I'm going to deny use of it wherever this policy is. So GitHub MCP, and let's just zoom in a bit here. And currently I have a policy that just says only I can access it, but I'm going to go ahead and add this no merge pull request policy. And I'm going to go ahead and save that. So the GitHub MCP server should no longer allow at least me to be able to merge a pull request. So let's go ahead and run this again. What we did before, creates a repository, creates the branch, it'll create a pull request. Hopefully it creates a pull request. Yeah, okay. And now it's going to go and try and merge the pull request. And okay, of course, it's a demo, but it should have failed that. Let's try it maybe one more time. Let me double check that I put that properly. This is the beauty of live demoing. Okay, no merge pull requests, GitHub MCP. Okay, we'll try it one more time. I can definitely say this does work. So with me, but that's okay. All right. So, uh, yeah, okay, let's try this again. This should apply it. Oh, whoops. Okay. Another side note, I didn't include the MCP server, so it just used the LLM. So that's why it didn't make tool calls. Okay, so let's go ahead and do this again. Hopefully this works. If not, I have a video I can share. Okay. I know we're almost at time here, but that's okay. We're wrapping up here. Okay. Okay, there we go. It failed. So because I added that policy, it did everything else, but it couldn't merge the pull request. So now if I come to here, we can see it. There we go. And so I don't know. That's pretty cool, I think. And let's go ahead and come back here. So yeah, here's some resources you can check out. Here's all the open source repos. I also created a MCP TypeScript template for anybody interested in building an MCP server. The MCP app demo is the chat I just showed you. Again, open source. And that's pretty much it. Thanks, everybody. And if you want, go ahead. You can grab the QR code here. This will go to the slide deck that I was just presenting. And if you want to connect with me, all the places you can find me online are at nickit.online. Thanks, everybody.